Now we continue with how to implement OrFilter. We are now going to look at the guts of the OrFilter class that we need to create. We've already learned that the class name is OrFilter, that it implements filter, and that we have a constructor that takes two filters as its arguments. And we have decided that those two arguments need to be things that get put into a collection. And for us, a collection whose size is flexible means an array list. And so we create a field which is an array list which contains filters, and we go ahead and give it a name, all good, because if any filter in this collection that says that accepts a given string means that this filter accepts that string as well, and that English description gives us the full definition of how our accept method should run. Don't forget, if we are implementing the filter method, if we're implementing the filter interface, we have to implement the accept method. That for us just means to iterate through the field all good. F takes on each of the values within all good because we're going to do it for each of them. And if F accepts X, then we're done. We return true. If we fail to return true for any of the filters in all good, we're going to return false. You may recall from our formal logic lesson, this code is identical to code that we created for all X construct in formal logic. We also needed the add method. This was the deceptive extra method, that invocation that was in the code of the problem that was easy to overlook. And the cool thing here is we delegate the job of adding a given filter that we're given to the field all good. And so all we have to do to add is add, because we've created our field all good. That is all we need to do to implement the OR filter. And so that when our code runs, in the setup we have the true, false, false over here. And then in the second table we have the true, true, false, true, which is exactly what this table calls for. And that completes our work on part A of this particular problem.